Okay, ready?
Yes.
So in this video we're going to talk about the various functional groups that you are responsible for in this unit. First we're going to start with ones that are just carbon. So we have alkane groups, where you have just carbon and hydrogen, no double bonds, just single bonds. And then we're going to represent the rest of the molecule with the letter R. So alkane is all single bonds. An alkene is a hydrocarbon chain with a double bond present. And an alkyne is when you have a triple bonded carbon present as a side chain. An arene group represents basically a benzene ring that's attached to the rest of the molecule. And these are the four most important carbon-based functional groups you're responsible for in this unit. Now we're going to talk about ones that contain just one oxygen. And the simplest one would be an alcohol, where you have the rest of the molecule, and then you have an O directly bonded to an H. An ether is when you have carbon chains, or the rest of the molecule, and then they're connected by a link to the oxygen. So this is essentially a primary oxygen. This is a secondary oxygen. So it's got two non-hydrogen things bonded to it. An aldehyde and ketone are essentially the same thing. It's when you have a carbon double bonded to an oxygen. The difference between them is an aldehyde happens on a terminal carbon at the end of the chain, whereas a ketone happens in the middle. Alright, so if you have more than one oxygen present, then you're talking about an acid, an ester, or an acid anhydride. So an acid, you have a double carbon double bond to the O and a single bond to an O, and then that oxygen is bonded to a hydrogen. And this is the acid molecule, or the acid component of the molecule, where this hydrogen can be donated as the oxygen can pull the electrons away from it. This would end up being partially negatively charged, or completely negatively charged, and that would be positive. An ester is essentially like an acid, except instead of that oxygen being connected to a hydrogen, it's now connected to another chain. An acid anhydride is like what you would get if two acids came together and lost water. So it's basically two acid molecules connected with an oxygen. Alright, if we're talking about ones that contain nitrogen, you have amine groups. So you can have primary, secondary, or tertiary amines. If you have two hydrogens on it, that's primary, okay, because it's kind of the end of the line, and it's just got hydrogens on it. If you have a secondary amine, you have it connected to more than one carbon. And if you have a tertiary, it's got no hydrogens on it, just carbon atoms connected to it. The other nitrogen-based functional group you're supposed to know is a nitrile group, which is essentially a cyano group. It's also called a cyano group because it's carbon double bonded, triple bonded to a nitrogen, like cyanide. Alright, so if you have nitrogen and oxygen, you can have nitro groups. So nitrogen, double bond O, and single bond O, and then connected to the rest of the molecule, will result in this oxygen having a negative charge and the nitrogen having a positive charge, which is also kind of why they're pretty unstable and used in explosives like TNT. Amides are when you have a nitrogen bonded to a carbon that has a double bond O. So this is essentially like an organic acid group with the oxygen being replaced by a nitrogen, and this is what happens in peptide bond formation. Right? When you have halogens, you just call it an alkyl halide, so it's just a halogen, which is either fluorine, chlorine, bromine, or iodine, connected to a carbon, and you can have an acid halide where essentially it's connected to a carbon that has a double bond O. So it's almost like an organic acid, except instead of the hydroxyl group here, you have a fluorine. Now, if you have sulfur-containing ones, it's either a thiol, which is essentially the same thing as an alcohol, where you replace the O with an S. You can have a thioether, where it's like an ether, except the O is now replaced by an S. Or, like the strongest organic acids would be sulfonic acid, so it's essentially like a sulfuric acid with the hydrogen on it. That's the acid component. And those are the functional groups you're responsible for knowing for Chapter 1.